Automatic Private IP Addressing (APIPA). Think of Automatic Private IP Addressing, or APIPA, as the network's emergency spare tire. It is a specialized feature of the Windows operating system that allows a computer to stay connected to its local neighbors even when the primary method of getting an IP address has completely failed. While APIPA prevents a total communication blackout, seeing it on your screen is almost always a sign that something is broken. To master this concept for your career and the CompTIA A+, you must recognize the magic numbers that define it and understand the IPv6 version of this same emergency behavior. The trigger, a failure to communicate. Under normal circumstances, when you turn on your laptop or plug in a desktop, the machine sends out a shout to the network asking for an address. This is the DHCP process. Your computer is looking for a DHCP server, usually your router, to lease it a valid IP address, a subnet mask, and a gateway. However, if the DHCP server is turned off, or if the cable to the router is broken, your computer will shout and get no answer. Rather than giving up and having zero identity, Windows triggers APIPA. The computer essentially says, "Fine. If no one will give me an address, I will pick one for myself." The identifier, 169.254. As a technician, you must memorize the APIPA address range. If you ever run the ipconfig command and see an address in the range of 169.254.0.1 through 169.254.255.254, you are looking at an APIPA address. The subnet mask for this range is always 255.255.0.0, or a 16. When a computer picks an APIPA address, it uses a technique called gratuitous ARP. It picks a random number in that range and asks the network, "Is anyone else using this?" If no one answers, it keeps the address. This allows every computer in the room that has failed to find a DHCP server to at least talk to each other, even though they are all broken. The major catch: no gateway, no internet. The most important thing to remember is that APIPA is non-routable. An APIPA address does not come with a default gateway. Because the computer picked the number itself, it has no idea where the exit to the internet is. If you have an APIPA address, you can share files with the person sitting next to you if they also have an APIPA address, but you will have zero access to Google, your email, or any website outside of your immediate room. In Windows, this often shows up as a yellow triangle over the network icon with the message, "Limited or no connectivity." The IPv6 version, link local. As we discussed in our exploration of the undecillion address future, IPv6 does things a bit differently. In the old IPv4 world, APIPA is an emergency state. In IPv6, this behavior is a mandatory, permanent feature. Every IPv6 interface automatically assigns itself a link local address, which always starts with the prefix FE80, FE80/10. This functions exactly like APIPA. It allows the computer to talk to its local neighbors without needing a server. The difference is that in IPv6, you keep this address even after you get a global public address. Troubleshooting, the path to a fix. When you encounter an APIPA address in the field, your troubleshooting brain should immediately go to the DHCP server. You should ask yourself, is the cable plugged in? If the NIC can't see the light from the switch, it can't reach the DHCP server. Is the router DHCP server alive? If multiple people in the office have 169 addresses, the router has likely crashed. Is the DHCP scope full? Sometimes the router only has 50 addresses to give out, and if 51 people show up, the last person gets an APIPA address. By recognizing that 169 prefix instantly, you save yourself hours of wasted time. You stop looking at the website settings and start looking at the physical connection to the router.